Okay, so receptors are generally structures that are able to respond to stimuli. With battery. Wait a moment. So one more time. Receptor is a structure that is able to respond to some stimulus. This may be some substance like a hormone. It may be some environmental stimulus like the temperature, like the mechanical vibration, like light, like sound, anything. So receptor is able to respond to it. What does it mean? That it needs this stimuli needs first to activate the receptor, and then activated receptor passes the information to other structures in the cell that something needs to be done. So first, we need to have some stimuli. This stimuli needs to be strong enough to be able to activate the receptor, because too weak signal would not activate the receptor. For example, if light is too dim, we would not be able to see anything because our receptors would not be activated. Later, it activates the receptor, and activated receptor gets the information into the cell. So reception, signal transduction, and response. Response could be anything. Yes, it could be production of some other hormone. It can be muscle contraction. It can be creation of new synapse, neurotransmitter release, anything. Yes. Critical thing here is that reception, signal transduction, and the response. Very good. About this next time. So we have a lot of different types of the signal transduction. For example, we have here coupling with the G protein. So we have some receptor. Receptors are usually the proteins that are in the cellular membrane, activated by some ligand. In this case, most of the receptors in the cellular membrane are activated by some ligands. Ligands are any chemical substance, quite frequently hormones. Then this is coupled with the G protein. As you can see, G protein is generating from GDP and then CAMP, generally speaking. So the CAMP would be created and it would activate further on. So generally speaking, the most important here is the CAMP that would produce the cell-specific response. So G protein, GTP, GDP, and then later CAMP. Here we have other type of the receptor that is connected with the guanyl cyclase. So guanyl cyclase is not creating CAMP as previously, because previously we had CAMP. Now we have CGMP. And generally, CGMP, in most of the cases, acts in opposite way as CAMP. So CAMP is generally acting in opposite way as CGMP. Yes, and the example of this are the receptors for the nitric oxide. Still, they are not all that we have. We have also some proteins connected with the phosphokinases, with the phosphatidylcholine. We'll not delve into too much detail with this. Just you need to know that something like the phosphatidylcholine is present. Maybe present at least. Okay. Why it's important, generally speaking? We already talked something about this. That this is important because thanks to different receptors, it may the same ligands may lead to different actions. So we, for example, have the wait a moment. For example, we may have some receptors that are responding to the same stimuli, but will lead to different types of the signal transduction. And the signal transduction is critical because different signal transductions would lead to different effects, and effect is what we care about. So effect is, for example, muscle contraction. Yes, is, for example, conduction of the electrical signal through the neurons. It can be anything. Yes, but this effect is what is useful, as the name suggests. So we care about it. Okay, thank you.